This is a miniature beach resort that shows the application of logic gates. We decided that the overlook of the project must be in nighttime to further improve the application of the logical gates using light-emitting diodes. As you can see in our project, there are 3 different main points. First is the mini hotel connected to a bridge with 2 light posts. Next is the sky lanterns that flew into the sky. And lastly is the lighthouse. So let's start with the mini hotel. The mini hotel has a light bulb inside, providing light during the night. The house is connected to a bridge that is lighted by 2 light posts. The 2 light posts connected in series is then connected to the hotel light in a parallel connection, which is connected to 2 switches also connected in series. This part supports the AND logical gate where 2 parallel connected switches are attached to the battery and loads. We chose to apply this kind of logic in this part given this reason. The hotel's electricity is generated only by a generator, symbolized by the first switch, and the second switch symbolizes the main switch of the hotel. This is the scenario because the beach resort is located in a faraway island where there is no source of electricity, so the owner of the island decided to have his own generator to supply his own home. So let's see how the AND logical gate works with this mini hotel. When the generator and main switch is off, the bulbs will not light up. If the generator is on but the main switch is off, the bulbs won't still light up. If the main switch is turned out but the generator is not powered, the lights will still be off. The light bulb and light posts will only light up if the generator is functioning and the main switch is on. Here's the truth table for this. In the first row of the P column, we have a true and also a true on the Q column, therefore it yields to true. Second one, a true on the P column and the false on the Q column results to a false. The false on the P column and the true on the Q column yields to false, and the last one, false on both columns, also result to a false. Let's move on with the sky lanterns. The beach resort is celebrating their first year anniversary, so the owner decided to conduct a lantern festival, celebrating their success and wishing for their luck for the following years. But because the island is kilometers away from the city, they decided to make a substitute for candles that will light up their lanterns. They used fuel cell containing 2 kinds of flammable materials, cotton and paper. This explains the application of OR logic gates. The 5 miniature sky lanterns and the 2 switches are connected in parallel, which is then attached to the battery. This gate was then applied to this part given that there are 2 possible materials that symbolizes the 2 switches, the cotton and paper. So let's study how this works. When the sky lantern is not fueled with either paper or cotton, it will not light up. But when the sky lanterns are only fueled by paper fuels, this will start to light up and fly. The same thing happens when lanterns only use cotton fuel cells. Lastly, when the sky lanterns are using the mixture of the cotton and paper as fuel cells, this will definitely light up. The truth table for the OR gate has also 3 columns. In the first column, P has a true. The second one, the Q also has a true, therefore, it statement is true. The second one, a true on the P column and the false on the Q column, is also true. The next one, a false on the P column and the true on the Q column results to true. And the last one, F on both columns results to a false.
Lastly, the lighthouse. A lighthouse is a tower, building, or other type of structure designed to emit light from a system of lamps to serve as a navigational aid for maritime pilots at sea or on inland waterways. In this miniature, we use the not logic gate because of the fact that the lighthouse is always turned on when it's already nighttime. The miniature in this scenario guides the small boats loaded with the invited visitors from the other islands to safely reach the beach resort. The lighthouse uses one bright white bulb which is connected to a knot circuit which is then attached to a button and battery. When the button was pushed repeatedly, making the light turn on and off, this signals that the officer in charge in the lighthouse received an emergency regarding the small boats, alarming the resort's rescue team to respond. Let's now see how this works. When the lighthouse was lighted up, this indicates that it was already nighttime, guiding small boats to reach the island. But when there is an emergency, the officer in charge turns off the light for seconds to indicate an alarm. The officer will continuously turn off and on the light until the problem was resolved. This means that the circuit was also continuously changing the flow of the current in the circuit. For the NOT gate, we have a truth table containing two columns, P and its negation. For the first one, in P, we have T, therefore its negation is F. The second one, false, therefore its negation is true.